Hello everyone, welcome to Tector.com. So far we have understood what is timestamp ordering, what is timestamp itself, and we have learned what is basic timestamp ordering protocol. Okay, so in basic timestamp ordering, we have seen that it enforces conflict serializability, right? But that is not the actual requirement. Sometimes we can enforce concurrency or we can achieve concurrency with view serializability. Okay, and that is the basically improvement of Thomas Wright rule. So as from name itself you can conclude that it is a different Wright rule. Okay, and it is an improvement of Wright rule on what we have on basic timestamp ordering. Okay, so in basic timestamp, this is the rule of basic timestamp ordering, where if transaction Ti issues a write X, then we compare whether the read timestamp of X is greater than timestamp of this transaction itself, or write timestamp is greater than transaction itself. Okay, if it is any one of this is true, then we abort, because from this we can be sure that a later transaction than this Ti has accessed the value. Okay, fine. Now we know that in view serializability we ignore blind writes, and that's why this case where if a later transaction has done some write operation over this variable X is ignored in Thomas Wright rule. Okay, so we will write it differently again. So this is the main modification. I have written it separately. So if read timestamp is greater than timestamp of the transaction, first one, then we abort it. So what I mean to say is, for this X, if read timestamp, it also has write timestamp, and now transaction Ti comes. Okay, so let's again take T1, T2, T3, T4 and so on, and it has timestamp value 1, 2, 3, 4. Fine. Now if read timestamp is greater than timestamp of this transaction, so let's say this Ti is 1, transaction T1 we are considering, and if read timestamp is 3, it means that a transaction which came later than this T1 has read the value. Okay, so we cannot perform write, okay, because later transaction has read, so we need to abort and roll back. Fine. But in case of write, we change the rule here, and if some later transaction has performed write, let's say this is 3, okay, some later transaction has performed this write, this transaction performed last write, then what do? We ignore the write operation by this transaction, okay, and but we don't abort and roll back, we continue the transaction. So basically what happens is, let's say here we have in some schedule I'm taking in between, so let's say here it has write X and here it has write X, okay, again write X, like this. Fine. So when this write X comes, okay, it means that this transaction, this later transaction, this is T2, this is T1, okay, so this later transaction has already performed some write, so we ignore this write, but we continue the transaction. Fine. So this is Thomas Wright rule. It will ensure view serializability, but it will not be able to ensure conflict serializability. So for Thomas Wright rule, the idea is simple, that as we know that the later transaction has performed some write, okay, so this write is now useless, and that's why we ignore it. Fine. So this was all about Thomas Wright rule, and in next lecture we will understand another concurrency control protocol, which is validation based protocol. So I hope you understand so far. If you have any doubt, please go to tector.com and ask your doubt. See you in the next lecture. Thanks for watching.